Did you learn subnetting with Class C addresses and then suddenly realize that wasn't enough? Maybe you're studying for the CCNA 200-301 exam, the new upcoming CCNA 2.0, or you've been searching for terms like IPv4 subnetting, VLSM explained, classless IP routing, classless subnetting, subnet mask explained, CCNA VLSM, variable length subnet mask. Desperately searching for something to help you learn how to subnet in a Class A or Class B address. Whatever brought you here, welcome. Here's the problem that we're solving today. You have a network that needs to support 1,200 hosts, 300 hosts, and then 50 hosts. Suddenly, the fourth octet, it isn't big enough anymore. It can't hold 1,200 hosts or 300 hosts. This is where many CCNA students get stuck. I see it all the time. Students tell me, I can subnet a Class C network, but I can't subnet a Class B. Or they ask me, will I be tested on anything below a /24 on the CCNA? The answer is yes. The current CCNA 200-301 doesn't explicitly say that you're going to be tested on the other subnets, but you will receive questions that expect you to be able to subnet Class B addresses at least. Maybe not laying out the whole network like you have to do with a Class C network, but they're going to expect you to recognize if a device is in the wrong network, no matter where it's subnetted. Also, Cisco can disguise these subnetting questions as ACL questions, routing questions, or NAT configurations, just to name a few. But you need to be able to recognize right away if there's a problem with the subnets. Okay, for this video, I already assume that you understand subnetting with block size for Class C addresses. That means the fourth octet. If you don't, that's okay. My CCNA series for subnetting goes through this method step by step. So just start at the beginning. Stop this video. Start at the beginning. And then come back here when you're ready. I'll wait for you. For everybody else, if you've already learned block size subnetting, or you've followed my method through and that's what you're using, so you already know how to do this. Class B VLSM is the same process as Class C VLSM. The math doesn't change. The method doesn't change. The only difference is that you're working with a larger set of numbers. Stick with me, and by the end of this video, you'll be able to subnet any Class B VLSM subnetting question. We'll subnet a 10.0.0/16 network to support 1,200 hosts, 300 hosts, and 50 hosts without calculators, without some sort of trick or shortcut. This method works for the CCNA 200-301, and I'm sure it's going to work for the CCNA 2.0 as well. And it also works for real-world networking. This is the CCNA study series. Let's get started. Here are our network requirements. 1,200 hosts for network A, 300 hosts for network B, and 50 hosts for network C. Let's just start by writing down network A's network ID. Since we are subnetting 10.0.0.0, that is what we start with. Next, we need to know our subnet mask. For that, we just use our 2 to the power of h formula. Now, if you will notice, my 2 to the power of table over here only goes up to 128 from working in the fourth octet. Well, that's all we needed. That's no problem. We can just keep going by doubling our numbers until we meet at least 1,200. 2 to the power of 8 equals 256. 2 to the power of 9 is 512. 2 to the power of 10 is 1024, and 2 to the power of 11 is 2048. All right, we just passed our 1200 host requirement. Here, the 11 tells us we need 11 host bits. Remember, host bits are zeros. And we put in our 11 host bits for our subnet mask. Now, we know there are 8 bits per octet. So here we have a dot after these 8 host bits, and then there are 3 host bits right here in the third octet. What are the remaining 5 bits? I hope you said ones, because that's our only option with binary. And then the rest, of course, are also ones. We have to follow the contiguous ones rule with a subnet mask and keep these ones on the left-hand side together. This gives us 248 right here in our subnet mask's third octet and a 0 in the fourth octet. Of course, octet 1 and 2 are still 255 because they have 8 ones in each octet. All right, as we have done before, we just take our magic number of 256 and we subtract the interesting octet from 256. Up until now, the interesting octet was always the last one, but now our interesting octet is the third octet. Here, where this subnet mask has been revised to 248, that's our interesting octet. All you need to remember for the interesting octet is that it is the octet we are modifying. So 256, our magic number, minus 248 equals 8. We have a block size of 8. Just like we have previously done, we want to calculate the next network ID, and that will help us to figure out each one of our individual subnets. So we add 8 here in the third octet. 0 plus 8 is 8. Now we have network B's network ID. It is 10.0.8.0. Okay, let's just go ahead and calculate our network C's network ID. We need to know the block size for network B that we're going to use. Network B needs 300 hosts. Going back to our powers of 2 table, we can see that we will need 9 host bits because 512 exceeds our requirement of 300. Now we count out 9 host bits. We put our dot here at 8, and then just one more 0. That ends up in the third octet. And what will we have? We have 7 ones to complete our 8 bits. 1, 1, 1, 1, 1, 1, 1, 0 converts to the decimal value 254. So we have a subnet mask for network B of 255.255.254.0. When we subtract the interesting octet of our subnet mask from 256, we end up with a block size of 2. We just add our block size of 2 to our interesting octet here in the network ID. So our next network ID is 10.0.10.0. Okay, now on to network C. We will calculate another network ID, even though we aren't required to have one for this subnetting problem. That will help us to figure out network C's range. So for network C, we are back down in our comfort zone here of the fourth octet. We only need 50 hosts for network C. We can see from our powers of 2 table that we will need 6 host bits. Putting our 6 zeros in here and then filling out the remainder of spaces with ones, we get our binary number of 110000. 10.0000. That converts to a decimal value of 192. So 255.255.255.192 is our subnet mask for network C. 256 minus 192 equals 64. So our block size is 64. Remember, the interesting octet is the one we have modified. So we're now moving down here to the fourth octet, the one we modified in the subnet mask. And that is where we add our block size of 64. So we add 64 to 0, and we end up with a network ID for the fourth and non-existent network of 10.0.10.64. Now that we have all of our network IDs, we can calculate our broadcast IPv4 address and our first and last usable addresses for all of our networks. This part might be a bit tricky at first, but you just have to remember that you are actually working in binary, not decimal, and you're converting the numbers to a decimal number after we subtract one bit. We will start here with the first network, network A, and we look at network B's IP address. We subtract 1 from that. Remember, we are not actually subtracting one decimal number, but we are subtracting 1 bit. For network A, we end up with 10.0.7.255. Let's complete network A here. For our last usable, we have 10.0.7.254. And for our first usable, we have 10.0.0.1. Let's figure out network B. For network B, we're going to subtract 1 bit from network C and get the broadcast IPv4. That number will be 10.0.9.255. Now, to complete network B, we're going to subtract 1 bit from the broadcast address, and we will have 10.0.9.254 for the last usable, and 10.0.8.1 for our first usable. Network B is done. Now, moving on to network C. We're going to look at our non-existent network and subtract 1. When we do that, we have 10.0.10.63, which is our broadcast for network C, and 10.0.10.62 becomes our last usable. Then we add 1 to our network ID, and we have our first usable of 10.0.10.1. All of our networks are now complete. And that's VLSM with Class B addresses. Same block size, same method, just applying it across the third octet. I hope you learned something about VLSM for Class B addresses today. You look like you learned something, and that makes me really happy. I hope to see you in the next video. Bye-bye for now.